In my project, I was asked to design a table for a doctor's patient's waiting room. Now, I decided to make a table that would be welcoming and warm, and I thought that the best way to do that would be to design a table that had round edges, especially because doctors' offices are normally very squared off. So, in order to juxtapose that side of the architecture of the room, I decided to make a rounded table. So, the shapes that I chose were two elliptical cylinders stacked up on top of each other, but the bottom cylinder is larger and the top cylinder is slightly off-centered and smaller. Now, here are the dimensions that I chose. My bottom cylinder is 36 inches long, 24 inches wide, and 8 inches high. My top cylinder, which I said was smaller and slightly off-centered, is 24 inches long, 15 inches wide, and 8 inches high. So I have the same height for both cylinders. Now, in order to calculate the total surface area of my elliptical cylinder table, I have to find the total surface area of both cylinders and then, as we will see later, add those two together to get my total surface area of the table. Now, the formula to find the area of an elliptical cylinder is pi times a plus b times h plus 2 times pi times a times b. Now, what are a, b, and h in this formula? A is the axis major, B is the axis minor, and H is the height. Now the axis major is, if you look up here, this top right up here, okay, and from the longest point across is 36 inches long, and from the width, the longest width is 24 inches. So by finding the radius of both, I will get the axis major and minor. So the radius of 36 inches is 18 inches, and the radius of 24 inches is 12 inches. Now I do the same over here with my top elliptical cylinder, but I'll explain that later. So now that I know what my A, B, and H are for my bottom elliptical cylinder, I'm going to go ahead and plug in those figures for the correct variables. So over here I have pi times 18 plus 12 times 8. All right, so I have 18, which is my A, the radius of here, 12, which is my B, which is the radius of 24 inches, and 8, which is my H, or my height, plus 2 pi times, once again, as we know it's A and B, so I plug in my 18 and my 12. Now I'm going to begin my calculations. Pi, I went ahead and added 18 and 12, so I have 30 times 8, plus 2 pi, and I went ahead and multiplied 18 times 12, and got the following figure. Now, the next calculation, I realized afterwards that I had made a mistake. So I left that mistake and I corrected it so that I could explain what I learned. I didn't simplify. I didn't go ahead and multiply the 2 and the 216. When I did my calculation, I just went ahead and multiplied originally 2 times pi times 216, and I realized it would have been simpler if I had multiplied 2 times 216, getting my total here, and then later multiplying pi. So that's what I did. So I have here I multiplied 30 times 8, got a total of 240. So pi times 240 plus, and I went ahead and multiplied 2 times 216, got 432. So I have pi times 432. And then I went ahead and multiplied pi by these figures, which we see here. I added them together, and then I have my total surface area of my bottom elliptical cylinder, the first figure that I need. Now I'm going to go over to my top elliptical cylinder. As I mentioned before, I had to find my A and my B, so I have the radius of 24 inches, which is 12 inches, and the radius of 15 inches, which is 7.5 inches over here. So I have my A, I have my B, and I have my H, which is my height. So I went ahead and plugged those figures into the formula, which is given up here, giving me pi times 12 plus 7.5 times 8 plus 2 times pi times 12 times 7.5. Here, I went ahead and added 12 plus 7.5, got a total of 19.5, so I have pi times 19.5 times 8 plus, and then over here, I made another mistake, and I left that and corrected it so I could explain what I learned. I did not multiply these in my next calculation, which is actually what I did over here, but for whatever reason I didn't do it here. And when I was correcting it, revising it over, I realized that. So here I multiplied 12 times 7.5 and have a total of 90. So I have 2 times pi times 90. So down here, I went and multiplied 19.5 times 8, have my total of 156, pi times 156 plus, and look, I made the same mistake as I did over here, but then I corrected it. I went ahead and multiplied, in hindsight, 2 times 90, getting a total of 180. So in reality, I have pi times 180. Then I went ahead and multiplied pi times both figures, added them together, and I have my total surface area of the top elliptical cylinder right here. Now I want to know the total surface area of my elliptical table. So obviously I'm going to be adding one surface area of one cylinder plus the total surface area of the other to get my total. Just to clarify, I have A1 is the total surface area of my bottom elliptical cylinder, right here. A2 is the total surface area of my top elliptical cylinder, right here. And A3 is the total surface area of my table. So I have A1 plus A2 equals A3. So I went and took that surface area, put it here, this surface area here, added them together, and I have my total surface area for my table right here. Now I want to find out my volume for my table. So just as with the area, I had to find the area of both cylinders and then add them together, I had to find the volume of both cylinders and add them together. So the formula for finding the volume of an elliptical cylinder is V, volume, equals pi times A times B times H. Now A, B, and H, we already know what those variables are referring to since we figured it out with our area. So we're going to see some similar drawings here, the original dimensions, and then I have over here the radius, my A, B, and H for my bottom elliptical cylinder. Over here I have the top elliptical cylinder, and once again I have my A, my B, and my H. So now that I know what my numbers are, I'm going to plug those into the formula that we have, which gives me pi times 18 times 12 times 8, A, B, H. In my next calculation, I go ahead and multiply 18 times 12 times 8, giving me this total, which I then multiply by pi, and then voila, I have my volume. Very simple. So for this right here is my volume for my bottom elliptical cylinder. Over here, I'm going to go ahead and plug in my A, B, and H for my volume formula, giving me pi times 12 times 7.5 times 8 for my top elliptical cylinder. Going to go ahead and calculate those numbers, multiplying 12 times 7.5 times 8 together, giving me a total of 720. I multiply that times pi, and here I have the volume for my the volume for my top elliptical cylinder. Now, just like my area, I want to add those together so I can get the total volume of my table. So I have V1 plus V2 equals V3. Over here, I clarify what each of those means. V1 equals the volume of the bottom elliptical cylinder, this number right here. V2 is the volume of my top elliptical cylinder, right here. And V3 is the volume of my table. So I'm going to add my volume for the bottom to the volume of the top, getting my total volume of the table. Now, what is the relevance of this project to the teaching profession? They are numerous. First of all, because projects are a fantastic way for teachers to help students to pull together from all the concepts that they've been learning over a certain amount of time. And not only do they have to pull all those concepts together and use all of them together in one project, they also have to make it their own in an intellectual way, because they have to process it all, apply them normally in a very practical way, such as designing a table. And through that process, it becomes their own, right? They become familiar with it, right? And they become, I guess, more sure. That happened to me, for example, with one of them. For example, I didn't know how to find the area of an elliptical cylinder before that. So not only did I have to look up that formula, but I had to use it twice and figure out how do I not only find the volume or the area, for example, of one cylinder, but of a table with two cylinders. And so it was very simple. I knew what I had to do as soon as I thought of it, but I had to make that process and I had to go through it. And even correcting it, I found mistakes that I had made. So when I went to my volume, even though it was a simpler formula, I felt that I was better equipped to keep going. What is the responsibility? Obviously, as a teacher, I have to know these concepts. I hope to one day be an ESL teacher, not a classroom elementary school teacher. But even so, even though I perhaps won't be giving projects like this, and I maybe will not be teaching math, I will be teaching students who need help with these subjects, who have these classes in English and could have these projects and will come to me, and I might have to help them with those things. So I still have to have knowledge of all these different aspects to be able to employ it with them, and also to be able to, when I my own self have doubts or anything like that, where I feel insecure in a certain field or a certain study field or whatever it is, I have to be able to take the responsibility to learn it well enough to be able to transmit it to them and make them feel confident and willing to take on the task.